So for the past 4 months or so, from January to the end of April, during the spring semester, I was interning at Garmin for a software engineering internship. Garmin, a brief overview. Garmin obviously is known for their GPS systems, navigation systems, as well as like their fitness wearables and their smartwatches. I mean, they have tons of products, but they have five main business segments: automotive, aviation, marine, outdoor, and fitness. The team that I worked on was in the aviation department, so working on, um, in general, I guess the aviation products are like flight decks, the technology and devices that pilots interact with when flying a plane. So my internship goals from a high level, the main goal was just learn, 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 ask questions, learn as much as you can, walk away from the internship with feeling like you gained a lot of knowledge. That's something that pretty much everyone I asked said. Like, obviously, I had specific objective tasks that I was supposed to do to contribute to the company. But as far as my own personal experience, everyone just said focus on learning as much as you can. So, but as far as those actual tasks, I had two main things. 99% of my time and effort was spent on fuzz testing for safety critical products. So, of course, being in the aviation department, the products need to be certified and tested very thoroughly because, if you have a website, like a basic website, the testing doesn't need to be that thorough. If the website doesn't work, it's kind of a nuisance, but it's not that big of a deal. With, aviation products, completely different. If the product does not work as intended, that can obviously cause loss of life. So the FAA has guidelines and I guess certifications that need to be done for these products before they can be put on the market. And then a small task I had towards the end of the internship, I spent maybe a week or two on, was modifying a script that was used for parsing source code files, which I'll get into later. One thing I really liked about this internship was the mentorship aspect, which I knew going into it. That was the thing I was most excited about. So the first day I got there, I was assigned a mentor, and I was very fortunate because the mentor I got he's a very enthusiastic person, very knowledgeable. I believe he's been at Garmin for 4 or 5 years, and I think before he started there, he was also an intern. So he's been there for a while, loves the company, loves the people, loves the projects. Um, Alongside the mentor, there's other people, other engineers that I could ask questions to. Um, there was a there was a handful. There was one or two full-time engineers that started around the time that I started my internship. So those are people that had experience with the same task that I was working on because they had worked on the same task as an intern. So I could ask them questions as well. My mentor just helped me get up to speed on my tasks the first few weeks and then was able to answer any questions. And of course, as I got more comfortable with the tasks, I didn't need to depend on him as much. And I was able to ask simple questions to the person I was sharing office with, which was nice because I didn't have to bother my mentor, have him come all the way to my office and all of that. There was also a few part-time interns that I saw in virtual meetings. These are just people who were going to school full time, but they had a internship lined up for the summer. So Garmin said, hey, if you want to work part time, 15, 20 hours a week during the school semester, you can. And they just did that remotely. And there was a meeting once or twice a week for us interns to come in and have discussions and share the problems we had to hopefully get help from other people. There was a handful of interns in there as well as some full-time engineers and my mentor who was a mentor to both of these part-time interns that I interacted with that we could all just discuss and help each other solve problems with the task we were working on. So the main thing I was working on, like I said, was fuzz testing. And what fuzz testing is, it's a more efficient module testing. So you can see on the right here, this is what the software we use to view what's called coverage. Coverage pretty much means make sure that each spot in the code is reached at some point just to make sure it's working as intended. So take, for example, a simple if statement. An if statement can either be true or false. That's what it can be evaluate to. If that if statement is only ever evaluated to true in all the hundreds or however many test cases, then what we'd say is the false condition is a coverage hole, which means the code that exists in the false condition, which could be an else clause, that code is never executed in any test case. So we can't actually ensure that its behavior is correct. So what we do is we in traditional module testing, you would create test cases manually, write the entire test case to make sure that each clause is hit, each branch is hit, um, just to make sure that there's no unexpected errors. The problem with that is that can be very tedious. You're manually creating all those tests, especially with like the type of code that this code base is, which is low level embedded drivers. It can be very extensive. Like there are some functions that were hundreds and hundreds of lines long. So writing manual test cases for each function in a file where there's, 20, 30 functions potentially, that's just not a good way, a good use of time. So use fuzz testing where instead of manually creating the test cases, you're really randomly generating test cases. There is some manipulation and things that need to go along with it too, because you need to pretty much say, this function takes these four arguments. Let's randomly generate the values for these arguments, see what coverage we get, and then once, we get that most of the work done, we can go in and do the more tedious manual work to make sure the coverage is complete. So part of that is fixing crashes or errors. Obviously, if you're randomly generating values, you'll generate very large values, which can be an issue depending on what you're doing with that value. So you'd go in and um, just make sure everything works, making sure crashes don't keep occurring. So the two main parts of this fuzz testing is one, you generate the fuzz vectors, and two, you then use those fuzz vectors in a module test. All a fuzz vector is a data structure that holds the randomly generated values, and then you feed those randomly generated values into the test case or into the function under test to ensure it's working as intended. The problem or the challenge with this fuzz testing is there's a lot of code that still needs to be tested. Each file will have, I mean, it varies, but at least probably a few hundred holes that need to be covered. And there's, however many files, there's at least 50,000 holes yet to be covered in the code base. So although I did do a lot of work over these 4 months, it really was like a drop in the bucket. And it's something that many people at the company on various teams are still working on this, and they'll probably continue working on it until, for at least another year. So it's a very long process. The small other side task I had is, um, well, what I ended up doing for the task was optimizing a script, but to explain the problem in the first place, there is a tool you can see on this previous slide in the upper right. This is a screenshot from the Bullseye coverage software that we use to view the coverage for files. There was a bug that was discovered in Bullseye that where a certain structure of code in a C file would cause Bullseye to report something incorrectly. So this script was created to work through and parse the C files and compare it to the Bullseye report file and find the occurrence of this bug. And then you'd have to manually go in and change the source code to then pretty much avoid the issue. So the original goal was to pretty much use the script, go in and fix the issues. The problem with the script was it ran too slow. It would I when I first started working on it, I just let the script run for hours, and it didn't finish. So I let it run overnight, and it still did not finish by the time I got in the next day. So clearly something had to be changed to make the script usable in the first place. So after a lot of tinkering and trying different things, the solution I ended up using was multiprocessing. So essentially, I would have 330 files or so that was being parsed. If you do it all with one process, it would take forever. Not to mention sometimes the program would stall. So what I did was I made the script able to use however many processes the user wants to use, and then essentially split up those 330 files into, say 20 processes. So instead of one process doing 330 files, you'll do 20 processes are each doing, 10 or 15 or however many um, files. So the overall script will run a lot quicker because things are being done in parallel. So relevant coursework for this internship, well, I guess first I should say, obviously working in embedded driver code, I was using C, the C programming language, and then with the script I was doing Python, so C wasn't relevant, but I'll get into that. So the classes where I use C were incredibly beneficial because those classes like Intro to C programming and operating systems, those were the only classes I had, or that was the only experience I had with C in general, outside of like a small amount of self learning with C or C++. So I feel like those classes definitely got me comfortable enough with C to then um, be able to get up to speed once I started working on these tasks for the internship. Operating systems was especially useful, not only for the C programming familiarity, but also because it talked about threads, multiprocessing, and all of those concepts. And that was obviously beneficial for the Python script task because if without that like prerequisite knowledge, I wouldn't have been able to find the solution that I ended up finding for that side task. Other classes that helped, mathematical foundations of CS, intro to digital design. These classes, I believe, were ones where I would use, bitwise operators and logical operators, and that those things definitely helped me reason about the driver code that I was seeing, because a lot of low level code like that is going to be using like bit shifting and bitwise operators and things like that. So classes where I was able to get familiar with that definitely helped me feel more comfortable working on these tasks. So a few challenges I had as an internship. Obviously, software development is in a nutshell just challenge after challenge. So, every day there were challenges I was working through, but overarching challenges that I had. One was Git, and I would say that was the most frustrating because Git obviously is a complex thing in the first place. But when working, a large team at a large company, the complexity is just increased tenfold. And not to mention at Garmin, or at least on the team I was working on, they use different Git paradigms. Like I was always familiar with Git merge and pull requests and that sort of thing. But at Garmin, they use rebasing and cherry picking and all these things that I had never heard of. So I had to get familiar with those ideas. And still, after 4 months, I can't say I'm at all comfortable with those ideas. But there's also a mental aspect of that, of working on a large team like that, where I don't want to blow up the Git repo by doing something wrong. So even towards the end of the internship, anytime I want to push something, I would ask my office mate to just help me do that, because sometimes there were issues that would come up that I wouldn't know how to solve. So it's good to have someone to walk me through it sometimes. Another challenge, of course, just getting up to speed on the task that I was given. I had, which was learning fuzz testing, so I had to learn the framework and the workflow, and that took me a few weeks to get used to. And of course, even 4 months into it, there were still new things I was running into. But overall, there was a lot of repeating problems. So seeing it once would help me solve it in the future. Of course, I had no experience or very little experience with testing in general, and I had never heard of fuzz testing. So it took a bit to ramp up on all of those concepts. But yeah, it's one of those things where practice every day made it a lot easier. And that was another challenge with Git. Like I was interacting with Git once, maybe twice a week, as opposed to the fuzz testing framework. I was interacting with that, 8 hours a day. So it was a lot easier to get up to speed on the framework and the workflow. And another thing, wasn't really a challenge, but a thing I really focused on and took away from this internship is learning how to ask good questions. It's very appealing when you to it's very appealing to ask questions right away as soon as you get stuck. You get stuck, you hit a wall, and you just want to ask someone to tell you how to solve it. That can be that can be the easier route, but it's not the more beneficial route. So I learned to really take a step back when I got stuck and try to solve it by myself. And if I really couldn't find a path, I would have to make sure before I ask a question to understand the problem well enough to even be able to explain it. Because a lot of times, the reason you can't find a solution to a problem is because you don't have a good enough understanding of what you're even trying to do. And this is something that is called rubber ducking in the programming space, where you just want to explain the problem that you're having out loud, even if you don't know a solution, just to make sure you understand what's going on. And often by explaining that out loud, it will make a solution apparent to you. So I would make sure before even asking for help that I had exhausted all the options I had. I would search online. I would explain the problem to myself. I would to make sure that I understand it correctly. And usually those three things would help me solve the problem. And if at that point I still didn't have a solution, then I would ask for help. And at that point I would be able to explain it well to a person who is, coming in, seeing the problem blind, and that would help them get up to speed on the problem to then help me more efficiently. Because there's nothing worse than someone asking for help and just saying, this doesn't work, make it work. Like, that's not a very effective way of asking questions. So those are that's probably the biggest takeaway I had, because when you're new, when you're an intern, it's incredibly important to know how to ask good questions, because that's really what you're going to be doing, uh, you know, 10 times a day. So, conclusion, by all accounts, I talked to my supervisor, talked to the senior team lead, talked to my mentor, talked to my office mate, other people I worked with. By all accounts, my internship went well. Um, there was like a review and evaluation at the end of the internship. I was told my communication was good, my performance was good, everything was satisfactory, and clearly everything went well, because I was fortunate enough to receive a full-time offer, and I'll be starting as a software engineer one in the same team, same department in June.